Hello students, welcome back. I am Rinkesh sir and today we are going to start with exercise 9.4 of chapter number 9, that is differential equation. Here we will use a new method to find out the general solution or particular solution, that is variable separable method. Okay, so let's start with exercise. For each of the following differential equation exercise 1 to 10, find the general solution. Okay. First question, dy by dx equal to 1 minus cos x upon 1 plus cos x. Okay, so dy by dx equal to 1 minus cos x upon 1 plus cos x. Okay, now 1 minus cos x, I can write it down as 2 sine square x by 2, and 1 plus cos x, I can write it down as 2 cos square x by 2. So 2 will get cancel. Dy by dx will be equal to sine by 10, sorry cos, it will be 10 square x by 2. Now variable separable means the y variable, I will merge it towards dy and x towards dx. So I will take dx on this side. Okay, so dy is equal to 10 square x by 2 dx. Now I can integrate. Now what I have to do? Integrate. So first separate the variable x with dx and y with dy. Here there was no y, so it's only dy. Now integrating on both the sides, integration of dy is equal to integration of 10 square x by 2 dx. So integration of dy, that will be equal to y, and integration of 10 square x. Okay, so what were we doing in integration for 10 square? We are converting into sec square. So sec square x by 2 minus 1 dx. Y is equal to integration of 10 sec square x by 2, 10x by 2, and as x is divided by 2 means multiply by 1 by 2. So what I will do, just a minute, 10x by 2 upon x is multiplied by 1 by 2, so 1 by 2 minus integration of 1 is x, and when we are integrating it we are putting a constant c. So the solution is y equal to 210 x by 2 minus x plus c. So this was about question number 1. So just note it down. Now let's move to the next one, that is question number 2. Question number 2 is dy by dx is equal to root of 4 minus y square. Dy by dx is equal to root of 4 minus y square. Okay, with dy. So this will be dy upon root of 4 minus y square equal to dx. Okay, now integrate on both the side, integrating on both the side. So what is the formula for integration of 1 upon a, so root of a square minus x square, sine inverse. So this will be equal to sine inverse y by a. So y upon what is a? 2. Okay, equal to integration of dx, x plus c. Okay, So sine inverse y by 2 equal to x plus c. So y by 2 equal to sine x plus c, or y is equal to 2 sine x plus c. This is the solution of question number 2. So just note it down. Question number 3. dy by dx plus y equal to 1. So I can write it down, dy by dx equal to 1 minus y. Okay, so variable like dy by dx, sorry, dy upon 1 minus y equal to dx. Now let's integrate on both the side. Integrating on both sides, so we will get integration of dy upon 1 minus y equal to integration of dx. So now integration of dy upon 1 minus y, that will be log of 1 minus y into, sorry, y is multiplied by minus 1, right? So it will be minus log 1 minus y, and that will be equal to x plus c. Clear? Integration of dx is x. So log of 1 minus y equal to minus x minus c, or instead of minus c I can write down plus c dash. So when I want to remove log, we know that if log x is equal to y, x is equal to e raised to y. That means 1 minus y will be equal to e raised to minus x plus c. E raised to minus x into, sorry, c dash into e raised to c dash. Okay, so I can write it down, 1 minus y is equal to, instead of e raised to c dash I can put constant. Let's take constant a, because e raised to c dash will be constant, e raised to minus x. Y will be equal to, taking on this side plus, and this will be minus. So 1 minus e raised to minus x. Okay, so this was about question number 3. Just note it down. Now let's see question number 4. Sec square x tan y dx plus sec square y tan x dy equal to 0. So first let's take any one term on the other side. I'm taking this on the other side. So sec square y tan x dx equal to minus sec square x tan y dy. Now variable separable method means x variable with x and y variable with y. Sorry, I just made a mistake here. It's dy and here it's dx. So tan y, I will shift it on here. Sec square y by tan y dy equal to minus sec square x upon tan x dx. Clear? Now integrating on both the sides, means integration of sec square y upon tan y equal to minus integration of sec square x upon tan x dx, and here it's dy. Okay, so now Here I can use fx, f dash x. Fx is tan y, f dash x is sec square y. So what is integration of f dash x upon fx dx? That is equal to log of fx. So in both the case, in denominator it is fx and in numerator it is f dash x or f dash y. So this I will get log of tan y equal to minus log of tan x plus c. Now instead of c I can also write down log c, because if c is constant, log c will be also constant. Okay, so now log, when it goes on here, tan y plus log tan x equal to log c. So now in logarithm, addition becomes multiplication. So it will be log tan x into tan y, that will be equal to log c. So I can remove log on both the sides. So tan x tan y is equal to c. Okay, so this is our question number 4. What I did first, I just took variables sec square x tan y on the other side, and then I separate the x variable to x and y variable to y. Then integrating on both the sides. So this was about question number 14. So just note it down. Now let's move to the next question, that is question number 5. Question number 5, e raised to x plus e raised to minus x dy equal minus e raised to x minus e raised to minus x dx equal to 0. Let's write it down. E raised to x plus e raised to minus x dy, e raised to x minus e raised to minus x dx equal to 0. E raised to x plus e raised to minus x dy equal to e raised to x minus e raised to minus x dx. And this goes on the other side, it will become plus. Now variable separable, so these the variables function having variable of x, we'll take it on the other side. So dy is equal to e raised to minus x, sorry, it's e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x dx. Okay, so now we have separated the variables. Now let's integrate on both the sides. Integrating on both the sides, we will get integration of dy equal to integration of e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x dx. Okay, now see here, this in the denominator. Okay, when you will take derivative of this denominator, e raised to x, its derivative is e raised to x, and e raised to minus x, its derivative is e raised to minus x into d by dx of minus, so minus. So this will be equal to e raised to x plus e raised to minus x. Derivative of, sorry, integration of dy is y, and in numerator I can write it down d by dx of e raised to x of f dash x upon fx dx. This will be equal to log of fx. So y will be equal to log e raised to x plus e raised to minus x plus c. Okay, so this is the solution of question number 5. So just note it down. Now let's move to the next, that is question number 6. Question number 6. dy by dx equal to 1 plus x square into 1 plus y square. So I can directly write it down, dy upon 1 plus y square equal to 1 plus x square into dx. Okay, now we have already separated the variables. I directly use this step. So now integrate on both the sides. Integrating both sides, I will get integration of dy upon 1 plus y square equal to integration of 1 plus x square dx. So now integration of dy upon 1 plus y square, that will be tan inverse y, integration of 1, that is x, integration of x square, that is x cubed by 3 plus c. So tan inverse y equal to x plus x cubed by 3 plus c. This is the general solution of question number 6. So just note it down. Okay, students, so that's it for today. Thank you.